Alright, we're going to do part 1 of 4.2, solving quadratics by factoring. Again, we've already done this, but I just want to make sure that we're on the same page, then we can do these problems. So, again, what we're doing today is that step 1, the first check mark, or bullet point. That's what we're doing today. These two will be tomorrow. Again, not difficult, just different. First, let's match up the equation with the name of the form. Well, standard form, we all know standard form, ax squared plus bx plus c. Vertex form, well, that gives us the vertex. Vertex is what, h comma k? Oh, which one has h comma k? That guy. So obviously then, this is factored form, and it looks like what they looked like when we factored. Two sets of parentheses, and maybe a GCF out front. Not a whole lot different. Zero product property. This is important. So when you solve these equations, first, you set it equal to 0. Which it is. Second, you factor it. It's already factored, so that's easy. So now we set each factor equal to 0. That's what we're doing here and here. And then lastly, just solve for x. And that's what we did. So in this first one, x minus 9 equals 0, we added 9. That doesn't look like much. Now, well, we can see what's here anyways. So x minus 9 equals 0, add 9 to both sides, x equals 9. 5x plus 2 equals 0. A little bit more work. We subtract 2. When we subtract 2, we're left with 5x equals negative 2. And divide by 5, so that's how we get x equals negative 2 over 5. So we can check them. When we substitute them back into here, if they equal 0, we're good, and they do. The first set of parentheses, when we plug in 9, is 9 minus 9, 0. 0 times anything else is 0. The second equation, we're plugging in a negative 2 over 5 for the x value. The second set of parentheses turns into 0. 5 times negative 2 over 5 is negative 2. And of course, negative 2 plus 2 is 0. 0 times anything is 0. So those are our solutions. 9 and negative 2 over 5. All right, we got another one to solve. So step 1, set it equal to 0. It is. All right, I'm not dealing with that. All right, try this again in different color, maybe a little thinner. All right, so equals 0, check. Factor. Oh, it's factored. Check. Third, we want to set the factor equal to 0. Kind of losing that there. And then lastly, to solve for x. So most of these we will have 2 solutions for, but we saw that the other day. We can either have 1, 0, or 2 solutions are possible. It all depends on what the graph looks like, but we'll put them all together in a little bit. So again, equals 0, good. Factors, good. Factor equals 0, so 2x plus 3 equals 0. And 3x minus 1 equals 0. So the second one, we add 1. 1's cancel out. We got 3x equals 1, divide by 3, and x equals 1/3. Please don't give me 0.3 repeated. Unless you can write out all of the 3's, I don't want a decimal. First equation, we'll subtract 3 first. 2x equals -3. And divide by 2. Whoop, that's supposed to be a 2. So x equals -3/2, or -1.5 if you'd like. Doesn't matter to me which way you write it. It's pretty straightforward. Nothing too crazy. Hopefully, nothing too crazy. All right, we got another one to do. We got to solve x minus 7 times 5x minus 1. And the two answers are somewhere over here. Well, x minus 7 equals 0. We would add 7 to both sides. So x equals 7. So that's one of them. Pretty quick. And then 5x minus 1 equals 0. So we add 1. Ones cancel out over there, which is the whole point. We get 5x equals 1. And to get rid of that 5, we have to divide. So x equals 1/5. And there we go. When it's already factored, these are pretty quick problems. Poll. How many different solutions does this equation have, and why? Well, if we take a look at this, x minus 9 squared. We do not distribute the 2 or the squared to x and 9. If you do, I will be upset. So what it really is x minus 9 times x minus 9 equals 0. So we set each factor equal to 0, but did the same thing, we don't have to do it twice. So x minus 9 equals 0, add 9 to both sides. So we have x equals 9 twice, but that's it, we only have the one answer. So there is one solution. So put that away. One solution. Submit. I guess we just go on. Diamond problems. We just got to get better at these. That's how you factor. Remember the top number. I don't want that color. Thought I was erasing. Oh, I was highlighting. So remember our diamond problems where it's 8, come on you, 8 times, I'm giving up on that one. I'm going to use this method. Alright, so remember, this is A times C when we're talking about in standard form. A squared plus bx plus c equals 0. So A times C is our product. And then B, which, there we go, is our sum. So we want two numbers to multiply to the top number, and we want them to add up to the bottom number. So we'll go through these really quickly. 56 and 15, that would be 7 and 8. 36 and 13, 9 and 4. 16 and 10, 8 and 2. 81 and 18, 9 and 9. 45, 14. Well, maybe I'm stuck here. So here's what we should do if you're stuck. Well, we know 1 goes into it 45 times. 2, nope. 3, yeah. 3 times 15. Now, how do I know it's 15? I did 45 divided by 3. Does 4 go into 45? No. Does 5? You betcha. It goes in 9 times. As you notice, as we go down our chart, the distance between the two numbers is decreasing. At first it was 44. then that was 12, then it's 4. So now there's only 3 numbers in between 5 and 9, 6, 7, and 8. Does 6 go into 45? No. Does 7 go into 45? No. Does 8 go into 45? No. So those are all the numbers. Any of those work? Yep, 5 and 9. 35 and 12 is 7 and 5. 32, 8 and 4. 42, a little bit tricky, and 23. We want kind of big numbers, so it's 21 and 2. 24 and 14 is 12 and 2. And then 30 is 5 and 6. So those ones aren't too bad. They're all positive numbers. We're just multiplying and adding. However, these ones, there are some negatives we have to deal with. And that's okay, we can deal with that, but we have to deal with them. So whenever we have a negative up top, whenever we have a negative on the top spot, that means one negative, one's positive. The bottom number then tells us which one's positive, which one's negative. So since they multiply to be negative 6, one has to be negative, one's positive, and they add up to 1. So that would have to be 3 and negative 2. 36 and negative 13, well 36 is positive, so they're both going to be the same sign, and they add up to negative, so they both have to be negative. Negative 9, negative 4. Negative 16 and 6 would be positive 8, negative 2. Negative 4 and 0. So they add up to be 0, meaning they're opposites. So 3 plus negative 3, 5 plus negative 5. Or in this case, since they multiply up to 4, that would be negative 2 and positive 2. Then we got 4 and negative 2, negative 8 and 1, 9 and negative 4, 11, negative 4, negative 7, 3, and lastly, 14, negative 2 times negative 7, and adds up to negative 9. So you just got to keep practicing those. You can go online and just search diamond problems, and they'll pump a whole bunch out for you, and you just keep working on them. All right, so solving. Again, our steps, keep forgetting that that's the go-to color. And now, there we go. Let's do some green, move it down. So standard form is our ax squared plus bx plus c that we're used to. We need it to be equal to 0 to start this. Again, it needs to be equal to 0. Then we factor. If I can write this. Factor. Then after that, we set the factor equal to 0. And that's not quite going as quickly as I want, so I will do this instead. All right, so this was supposed to say factor equals 0. And then solve for x. So we're looking at our equation. X squared plus 9x equals negative 20. Is it equal to 0? No. So that's our first thing we got to do. So we add 20 to both sides. On the right side, it cancels out. We get 0. The whole reason we did that. Now 20 is not like terms with x squared or 9x, so we just leave it hanging behind both of them. So it's x squared plus 9x plus 20 equals 0. Now we factor. Diamond problem. Coefficient of x squared is 1, so 1 times 20 is 20. Middle number is 9. We want two numbers that multiply to 20 but add up to 9. Well, that would be 4 and 5. Again, because we have an a value of 1, because the coefficient of x squared is 1, we can skip right to here, which is nice. Again, still equals 0. So set equals 0, good. Factor, good. Factors equal to 0. All right, we got to do that. X plus 4 equals 0. X plus 5 equals 0. So we do the opposite operation, and we can get what x is. Now both of these started off as positive factors, but when we solve them, because we're doing the inverse of the opposite operations, they turn into negatives. So x is -4 or -5. And it can't be and, because obviously x can't be two things at once, no matter how hard it tries. All right, we got some more examples here, so let's nail these guys down. So first one, equal to 0, cool. Factored, no. So again, coefficient of 1 is going to help us out. So 1 times 64 is just 64, middle number 16. What two numbers multiply to 64 and add up to 16? Well, that's 8 and 8. Again, because our a value, the coefficient of x squared, is 1, we can skip right to here. So we got it factored. It's equal to 0, but now we set the factors equal to 0. Well, if you notice, hopefully you notice, that x plus 8 is written there twice. We don't need to solve it twice. It's going to give us the same answer. So x plus 8 equals 0. We're going to subtract 8, and x equals -8. Not too bad. Pretty quick problem. Now this next one, I have a feeling it's going to be a lot more work. So first off, it's not equal to 0. So let's subtract 6 from both sides. 2x squared minus 1x minus 6 now, because there's no like term, so it just stays there. And of course 6 minus 6 is 0. Now we have our equation. It's equal to 0, gotta factor it. There is no GCF. So we got 2 times -6, or -12. And we multiply the a value, the first term, by the last term. And then the middle number is the bottom. Now, don't put the x in the diamond problem. X's and variables do not belong in the diamond problem. So what two numbers multiply to -12 and add up to -1? That would be -4 and +3. Now we can't do the shortcut because we have a coefficient of x squared that's not 1, but that's okay. So we'll keep 2x squared, we'll keep -6, and it's still equal to 0. But now we're splitting up that -1x into -4x and a +3x. From here, we factor by grouping. You can do the box, whatever method works better for you. I'm going to take out a 2x. Whoop. Don't have a 2 left. I have an x minus 2 left. I can take a 3 out of the second pair. Whoop. These are the same, like they should be. So x minus 2 is part of our factoring answer anyways. We take out the x minus 2, so what do we have left? 2x plus 3. Now, whereas I'm sure all of us can see this, I'm going to rewrite it. Thought I was going to rewrite. X minus 2 times 2x plus 3 equals 0. Whoop, 0. So it's equal to 0. Check. Factored. Check. Now we set each factor equal to 0. X minus 2 equals 0. Really easy. Add 2. So x equals 2. One answer. And then we do 2x plus 3 equals 0. And again, it's a positive factor, so we're going to have a negative answer. And because we have a coefficient of x that's not 1, we're going to have a fraction. We're going to have a negative fraction. So of course, the first thing we do is get rid of that -3. So we get 2x equals -3, and divide by 2. So x is -3 over 2, or -1/2, or -1.5. And we don't really care how you write it, as long as you write it correctly. So again, we look at a different color. Step 1, set it equal to 0. Step 2, factor. Step 3, set them equal to 0. And then step 4, solve them up. I think we can do this. Word problems. So this one's not all that bad, but it is important that we can do these. So a museum vault has an outer steel wall with a uniform width of X. So that means that's X, that's X, that's X, and that's X. The area of the museum vault ceiling and the outer steel wall is 1,664 feet squared. What is the width of the outer steel wall? Well, we got to get an equation first. So we want the area of the top rectangle. So it's just length times width. It says that here. So right now we know that this to here is 40. But we need to add on these two x's because we have that extra length now. So 40 plus x, or 40 plus 2x. Similarly with the other dimension, it's 20, but then we have two x's to add on. So 20 plus 2x. Oops. Kind of running out of room here already. And then that equals 1,664, because that's our area. So now we have to multiply this, because we have to set it equal to 0. Well, to do that, we have to subtract 1664. To do that, we have to have regular numbers. We can't have factors, so we have to multiply it out. When we multiply it out, 4x squared plus 120x plus 800. See if I can, nope, can't do that. And that equals, squeeze that in, 1664. So we're going to subtract the 1664, 4x squared plus 120x. There's no other x's, just leave it alone. 800 minus 1664 is a negative 864, and now it equals 0, which is really what we wanted to do. Now we got to factor it. So we're going to divide and factor out of 4. So when we write our factoring answer anyways, we got a 4 chilling out front. And it will be equal to 0 because that's what it's equal to now. So when we divide that 4 out, we get x squared plus 30x minus 216. So we do our diamond problem. Coefficient of x squared is 1, so 1 times negative 216 is just negative 216. And our bottom number is the middle one there, the b, 30. Well, if we're looking for two numbers to multiply to negative 216 and add up to 30, that would be positive 36 and a negative 6. And because our coefficient of x squared is 1, we can skip right to x plus 36 and x minus 6. So now it's all factored. So we set all the factors equal to 0. 4 equals 0, x plus 36 equals 0, and x minus 6 equals 0. So the first one, 4 equals 0. That doesn't make any sense. 4 isn't 0. So it doesn't mean anything for us. X plus 36, we subtract 36 from both sides, we get x equals negative 36. Can that be an answer? Well, what does x stand for? The width of the steel wall. Can we have a negative width? I don't think so. So even though that algebraically worked out, in real life, that's not our answer. And then we have x minus 6 equals 0. We add 6 to both sides, so x equals 6. Can it be 6? I don't see anything stopping it. we'd have sides of 20 plus 12, so 32, and 52. And that sounds about right. So yeah, x equals 6, that works. It's a lot of work, but none of the steps are really that difficult. All right, one last problem, and we'll call it a day. So a picture inside a frame has an area of 375 centimeters squared. So that is just this part. It's not anything to do with the frame. It's not very drawn out very well. And then from here to here is 30. Here to here is 20. And then we have this little picture frame. We got an x value there, x, x, and x. So we have x on all four sides. It's kind of how frames work. If we didn't have a frame on the other side, the picture would just fall out. So again, our area is length times width. We don't really have the length and the width yet. We want to find, we know the area of the inside, so we got to find the side lengths or the dimensions of the sides. So the whole thing is 30, but I don't want to include x, and I don't want to include the other x, because I just want from here to here. So that side now becomes 30 minus x, because we took off those two frames, the two borders. So 30 minus 2x is one factor. Now we're going to do the same thing going across. We want here to here. So we already have 20. But then, just like with the 30, we're subtracting off x both sides because it's on both sides of the picture. So when we simplify that, we get this, and the area is 375. So again, just like our last problem, we multiply that out. When we do that, we get 4x squared minus 100x plus 600 equals 375. So we still can't solve it because it's not equal to 0. So we subtract 375. So 4x squared minus 100x plus, now 225 equals 0. Do our diamond problem. So now it's 4 times 225, or 900. And our bottom number is our b, the middle term, negative 100. Kind of big numbers. So we just got to make sure that we keep guessing, try and get something that works. Since they multiply to become a positive number but add up to be negative, they're both negative. In fact, they are negative 10 and negative 90. Now, unfortunately, our coefficient of x squared is not 1, so we got to do it the long way. 4x squared stays the same. Instead of negative 100x, we have negative 10x and negative 90x. And then we still have our 225, and of course all that equals 0. Let's do the box this time. Well, it takes up more space than the parentheses. So 4x squared, negative 10x, negative 90x, and 225. So out of the left two numbers, I can take out a 2 and an x. The right column, we can take out a negative, because the first number is negative, and 5. Now going with the rows, top row, I can take out 2x. Bottom, I can take out, a toughie, I don't know what we can take out. So, just like anything else, get out your calculator and divide. I'm thinking What about 45? So it is negative 45. So you gotta make sure you have the greatest common factor. All right, so we're at 2x minus 5. 2x minus 45. And that equals 0. So now we're going to set each factor equal to 0 and solve for x. But before we do that, we need to clear this up so I can actually write it somewhere. All right, that's enough room. Let's get a good color, the best color, green. If you don't think so, you're wrong. So we set each of these equal to 0. Now, because the coefficients of both of these are not 1, we got 2 and 2, we're going to have fraction answers. And because both factors are negative, we're going to have positive numbers. So we're going to have positive x values that are fractions. So we add 5 and divide by 2, so we get x equals 5 over 2, not x, not 2 over 5. 5 over 2, or 2.5. Second equation, we'll add 45. So 2x equals 45. Divide by 2, so x equals 45 over 2. Kind of silly, it doesn't simplify. Or, that's 22.5. Now, you could put it as 22 and 1/2. You can leave it as 45 over 2. Personally, in this problem, I like the decimal, but it doesn't really matter. All right, we're almost done. We just gotta check our answers, make sure that they can actually happen, because if they can't, that kind of stinks. So we have side length 2.5. That's not too bad. 2.5, or another 2.5, so 20 minus 5, and 30 minus 5. We can do that, that's fine. 22.5. Well, on the one side, we have 30 minus 2 times that frame. So 30 minus 45. Unless you have a ruler that we can find negative length, I don't think that answer works. So we only have one real answer. Now it actually had two solutions, but only one actually made sense with the context of this problem. And that's 4-1, or 4-2. So much longer. Well, and I'm still recording.